You know, we flip a switch and boom, light fills the room. It's so simple, right? Instant control. It's something we do dozens of times a day without even thinking about it. But have you ever just stopped and wondered what that control looks like on a massive scale?
I mean, it's one thing to control a single light bulb in your house, but how in the world do you turn off an entire city? Or maybe more importantly, how do you safely manage the unbelievable amount of power that's flowing through our grid, protecting it from problems, and making sure everything stays on reliably and safely?
Well, as you can probably guess, you can't just use one gigantic light switch. It actually takes a whole team of highly specialized devices, a family of switches and protectors. These are the unseen guardians of our power grid, and today, we're going to meet them.
Okay, let's start with the most fundamental player on the team, the absolute bedrock of electrical safety in these high-voltage systems. It's called the disconnecting switch, or just the DS.
So, what's its job? The whole point of the DS is to open or close a circuit, to create a big physical gap. But, and listen up, because this is the most important part, it can only do this when the circuit is already dead. Think of it less like a faucet you use to turn off the water, and more like a safety gate you only close after the water has already been shut off somewhere else.
And here's what one of these things looks like in the wild. You can see those huge heavy-duty contacts and the massive insulators. It's clearly built to handle crazy high voltage, but its job isn't to fight the current. Nope, its job is to provide a clear, visible break in the line after another device has already stopped the flow of power.
And that brings us to the golden rule, the one thing you never, ever break. You absolutely cannot operate a DS on a live loaded circuit. Trying to open this thing while thousands of amps are flowing would create a massive, incredibly dangerous electrical arc. Its #1 mission is safety. To create that visible air gap so utility workers can literally look at it and be 100% sure a line is dead before they get to work.
So this brings up a pretty obvious question, doesn't it? A disconnector is perfect for guaranteeing safety on a deadline, but our power grid is, well, it's always live. So what happens when you need to switch a circuit that's active and carrying its normal everyday load of electricity? Well, that's where our next guardian steps in. Meet the load breaker switch, or LBS for short. The LBS is the answer to that very question. It is specifically designed with features to handle the challenge of interrupting flowing normal current. It can safely break a live connection while it's under load without creating one of those dangerous, uncontrolled arcs. It's really the workhorse for all the routine, live switching that needs to happen. But the LBS does have its limits. It's tough, but it's not invincible. It handles the day-to-day electrical loads just fine, but it is not built to handle the catastrophic surge of current you'd get from a major fault, like a tree falling on a power line and causing a massive short circuit. For that kind of emergency, it needs a partner, which is why you'll often see it paired up with a high-voltage fuse.
Okay, so let's recap. We've got a switch for dead lines and a switch for normally loaded live lines. But what happens when that fault, that tree branch, occurs way out on the distribution system? How do you find and isolate the problem automatically without having to send a crew driving for miles and miles trying to find the issue?
This is where things get really smart. This brings us to the brains of the operation, the sectionalizer. Think of it as a smart switch that's a key member of an automated fault-finding team.
Now, the sectionalizer is clever, but it's not a solo hero. Just like the disconnector, it can't interrupt a massive fault current by itself. Instead, it works in perfect coordination with an upstream partner called a recloser. So the recloser is like the heavy-duty automatic switch that can handle the big fault and then try to restore power. The sectionalizer's job is to count and think, and basically tell the recloser when to stop trying. Okay, let's walk through this little dance of teamwork, because it is really cool. So a fault happens, bam, the main recloser up the line feels it and opens, killing the power for just a second. The sectionalizer downstream sees the power go out and thinks, okay, that's one. Then the recloser automatically closes again, hoping the fault was just temporary. But if it's not, the fault is still there, and the recloser opens again. The sectionalizer counts 2. After a preset number of tries, the sectionalizer knows the fault must be in its section of the line, so during that next brief outage, it opens itself up. When the recloser closes that final time, the bad section is now isolated, and power is back on for everyone else. It's just an ingenious way to shrink the size of an outage, and it all happens automatically.
And finally, we get to a device that I am almost certain you have seen on utility poles in your neighborhood, even if you had no idea what it was called.
It's the protective cutout switch.
The cutout switch, or COS, is a fantastic little hybrid. It's both an automatic protector and a manual switch all rolled into one compact package. Its main job is to act as the primary bodyguard for the transformers that power our homes.
And there it is. You've definitely seen these, right? That gray tube thing hanging at an angle, that's what holds the fuse. They are the essential link between the higher voltage line on the pole and the transformer that steps it down for your house.
So the COS plays two really critical roles. First, if there's a problem or a big surge, the fuse inside blows. It sacrifices itself to protect the much more expensive transformer. And when that fuse blows, the holder often swings down into an open position, which is a perfect visual signal to a utility crew that, hey, something's wrong right here. Second, a worker can use a long insulated pole, hook that ring, and pull it open manually, using it just like a disconnector to safely isolate the transformer so they can work on it.
So how does this all fit together? This table really just nails it. You can see their distinct jobs laid out perfectly. The disconnector, on the far end, can't switch any current at all. It's just for safety. The load breaker? Yep, it handles the normal stuff, but not a fault. The sectionalizer is the smart one that also can't break a fault. And finally, the cutout switch. All thanks to that fuse can actually interrupt both. Each one has a specific strength, a specific purpose on the team.
So at the end of the day, there's no single master switch that does it all. The incredible reliability of our power grid really comes from this interconnected team of specialized guardians. Each one plays a vital, very distinct role, from simple safety isolation all the way to intelligent automated fault finding.
So I'll leave you with this final thought. The next time your lights flicker for just a second and then pop right back on, don't be annoyed. Be impressed, because you might have just witnessed this invisible automated team of reclosers and sectionalizers doing their job perfectly, finding a fault, isolating it, and restoring your power in the blink of an eye. It's a silent, brilliant dance that happens all around us every single day.